Hello students, this is a problem in photoelectric effect. First let's read the problem. In photoelectric effect, the work function of a metal is 3.5 electron volts. The emitted electrons can be stopped by applying a potential of minus 1.2 volts. Then you have four options here. We need to find out which options are correct. First option is the energy of the incident photon is 4.7 electron volts. Second option is the energy of the incident photon is 2.3 electron volts. Third option, if higher frequency photon to be used, the photoelectric current will rise. And the fourth is when the energy of photon is 3.5 electron volt, the photoelectric current will be maximum. Now this is a problem from photoelectric effect and we are using two concepts here. The first concept is the photoelectric effect and the electron emission due to light incident on the metal. So there what we have is we have Einstein's equation. Einstein's equation. So what does this equation say? It says that the energy, maximum energy of the electron emitted is equal to energy of the photon, that is incident, minus the work function of the metal. So this is the first concept. Second concept is the concept of stopping potential. Now stopping potential, let's call it Vs, is the potential which is to be applied in negative direction. So that's why we have negative here. This is to be applied in negative direction so that it will stop all the electrons from reaching the other electrode. So that means you can say that the charge of the electron multiplied by the stopping potential should be equal to the maximum kinetic energy of the electrons. So these are the two equations we can use to solve this problem. Now other thing we need to remember is that this quantity, if you actually take the voltage and multiply with the charge of electron, you will get this in joules. But we have been given the value in electron volt. So we need to calculate this in electron volt. So when you do in electron volt, so that energy will be equal to the energy in joules divided by the charge of electron. So it's basically the potential, the voltage expressed in electron volts. So we can say the first number is that the maximum kinetic energy of the electrons are, so our stopping potential is 1.2 volts here. We'll ignore the negative sign because that basically says that the voltage is applied in negative direction. We'll only take the magnitude. So that is equal to 1.2 electron volt. The next is that the working potential. We'll apply that in Einstein's equation. So we get E max is equal to energy of the incident photon minus the work function, that's equal to 3.5 electron volts. If you subtract these two equations, then what you get is the energy of the photon is equal to 3.5 plus 1.2, that's equal to 4.7 electron volt. So if we look for the options, so we have an option here, energy of the incident photon is 4.7 electron volts. So that will be the correct option. Now the other options, if we have a quick look, the energy of the incident photon is 2.3 electron volt. So that is definitely wrong because we found that it is 4.7 electron volt. Next is, if higher frequency photon be used, the photoelectric current will rise. Now here we know that every photon can dislodge only one electron. So frequency of the photon really doesn't change the number of electrons that are going to come out. It will only change the kinetic energy of electron, and hence to increase the current we need to have more number of photons. So frequency is not going to be the correct option. Now the fourth option is when the energy of photon is 3.5 electron volt, the photoelectric current will be maximum. Now you see here the work function of the metal is 3.5 electron volts, and when energy of the photon is exactly 3.5, then you find that the maximum kinetic energy is 0. That means there will be 0 current. There will be no electron which will be able to reach the other electrode. So this is also a wrong option. So we only have one correct option here, that is option A. So our answer is option A. I hope this cleared your concept on stopping potential and Einstein's equation, and you have learned how to solve this problem. Thank you.